NaOH2 buffer solution containing that cause addition of sodium hydroxide to buffer solution containing this causing pH. Okay. So we have buffer incoming hydroxide neutralized by exit. And how does pH change? Increase or decrease? Does pH increase or decrease? Without doing any calculation.
Decrease.
Increase? That was a strong base.
Okay, so this is a buffer. So buffer would have a certain pH, okay? Certain pH. Without knowing any number, any calculation, you are adding base to buffer. So pH should increase. We are not doing any calculation. Okay? Increase. Alright. Because sodium hydroxide react with, well, this guy react with what? Acid, right? Acid. So originally we have, so there are several ways to see it. Buffer is already have certain pH and then you're adding base, that's why pH increase. Or buffer has pH because it's balanced, but when you put this guy, you are removing certain acid, that's why pH increase.
So yeah, because I'm getting confused on the terminology. So say if you have like a pH of 7 and it goes to 8, is that increasing or decreasing pH?
pH increasing.
It's increasing.
Yeah.
Okay, so I thought increasing was more simple.
So, how come it doesn't react with just the C2H3O2, but it reacts with the whole thing, the HC2H?
Why this guy do not react to this guy?
Yeah.
Because they are same base and they are same kind of base, they do not react. So actually react with base. The reason is that when we say reaction,
I see.
let's see, okay, all right, that's good. So I think we have a similar problem down here. This guy. So this time we still have, oh no, that's different. This is amine, constant base. This is a conjugate acid. So this will also have certain pH. When you are adding acid, it will become more acidic. pH should go down. pH should go down, and then this will react with, because the acid, it will react to the base portion of buffer. It reacts with this guy. Okay. Now 19.
That one you were just doing was decrease?
Oh, this guy?
Yeah.
Yeah, because you are adding acid.
The strong acid, yeah.
Yeah, so pH will go down. So which of the following is the most effective buffer for pH value of 7.45? So in Handel's hospital, you can pH equal pKa plus conjugate acid and conjugate base. To be most effective, you have to have equal amount of both. So pH should be equal to pKa. But pH is this guy, pKa will be also the same guy. Now Ka was okay. So Ka value is given right there. Why don't you find out hydrogen concentration, because if you remove P from both sides, hydrogen concentration should be equal to Ka. And then pH was what, 7.45, hydrogen down to 7.45. You will have to do calculation of this. What do you get? There's only one guy has 8. So is that close to this one? Or it's 8 or 7? That's 7 that missing. Okay. This is small number. This is a little bit above. No, actually, yeah, it's above. And the 7 will be even more above. So 7 doesn't count. So that should be this. Now that's from calculation. What about this? What are they asking? Oh yeah, just from calculation. That should be this guy.
If there's like a question like this on a test, would it be okay if you switched around, like say?
Calculate pK from this guy.
Yeah.
That is fine.
Okay.
But then you have to calculate 5 of them. Right? You have to convert 5 of them. You convert only once in the seed, that will be faster. But you can do that as well.
Okay.
Yeah.
All right, thank you.
Alright. Thank you. Mr. Bottom mixture will be buffer when dissolved in a liter of water. Which of the following mixture will be a buffer? Okay, which is a buffer? Alright. We do not use strong acid base for buffer. Strong base, strong acid doesn't count. Strong acid is salt. No? Weak acid, strong base, weak base, strong acid. Now, to have buffer, you have to have a weak acid or conjugate base, or weak base, or conjugate acid. Conjugate acid. Otherwise, if you're going to have strong stuff should have less than weak one. So this guy has number smaller than 2. That will make buffer. This guy is equal amount, so you do not have buffer. So that's this. That's number 18. This is just number. Let me hang on. Oh, this is horrible. So it's a pH change. So actually, they actually ask this question actually exam, okay? So you may have to expect. You see this guy, right? pH change when acid is added to a buffer solution. So you're gonna have to calculate pH of buffer first. That's your initial pH. You have to also calculate pH later. Now pK will not change constantly will change. Okay. And what we want to find out is delta pH, which means final pH. Wait a minute, this tissue is small. Lowercase. Final pH minus initial pH. That's what you are looking for. But Ka value does not change, right? So even you don't have to calculate this guy. You just subtract it. It will be low. I mean, you can do it. You can just calculate individual and the subtract. That'll be fine. But if you want to just save a little bit of effort, you don't have to calculate. Just subtract it. Log A initial and actually final minus log A initial HA initial. And also if you know logarithm property, anytime you have subtraction, there will be division inside of logarithm. Which means I could write this one as I'm doing just some mathematical, just shortcut. You don't have to do. You can just use this one. And then once you did, you just subtract that, be fine. But you're gonna do extra calculation thing twice over time. It's not necessary. But it's okay if you do it, whatever you feel comfortable. So I have to find out constants of each guy. But initially, proposition is this more. Yeah, initially I have ammonia 0.20. Initially ammonia 0.20. 0.30. And then later, since this guy is 400.2 80 millimole. This one is 120 millimole. That guy is 5 millimole. That guy will cancel 5 all over this guy. So if you just cancel this one, turn into 75, this one turn to 125. So ammonium later 125. Exit 125. Base 75. So that should give me an answer.
Does the base go on top? Why does it flip in here? Like why isn't it 0.2 over 0.2?
Here,
No, the other one.
here.
Yeah.
We need a difference, so we have to subtract it. So we have negative logarithm.
And then you divide that.
Yeah, divide. Okay, we're going to divide inside the logarithm. We're going to flip. Okay, that's how it is. Now that was number 21. 22. The proposal containing that guy H says, wait a minute. I thought it's a similar problem. Okay. exchange added to this buffer solution. The pH will, okay. We did that. Last one. Calculate pH of buffer solution made from this. Okay. Oh, this one is, I think this one is just simple. pH just, it's a Henderson hospital. Acid is 0.15, base is 0.25, negative low. Ka, we don't have, we have Kb. So 10 to the negative 14 goes up there. Kb value goes down here. Then, that's the answer. Any question? So it's more become challenging, right? Question become more, and not only more, it's more complicated than before. Question will be like that. But it's good to know, realize question will be like that. So then you'll be better. Are you ready for next one? So you can write down why I'm going to just explain a little bit more about the next step. So far you learned about weak acid, weak base, strong acid, strong base at chapter 16, and that's the basis of following chapter, current chapter. Here you just learned about ice table setup. Okay? And then coming into chapter 17, you did the buffer. Buffer is basically mixing weak acid or weak base with conjugate. Okay. And we also learned about salt. If you put salt in the water, it could be acidic or basic, and you can show certain pH. If you combine all together, everything together, then the next topic, titration. You may definitely titrate, just mix acid base together, and then end point, right? That was more a qualitative approach. In the following slide, titration every of this. You need to know everything to understand titration. Okay? Right. Let's do titration now. So titration is, that's what you think. You already did titration in the Chem 1. You did in the lab, you just mix the acid base, and then see what's the end point. That end point, your indicator change color. Okay? That's what we are talking about. Just now we are using numerically, qualitative, quantitative. Okay? So any solution that was unknown, so you want to find out concentration of this guy. So you got some sample from the liver side, the leg side, and you want to know what's in there. That's what you call analyze, because you want to analyze that guy. But in this case, it will be acid or base. And then you have opposite of guys, which means if you have acid here, you use base to titrate. We call that a titrant. And then if you put equal amount of the titrant, like analyte That's when we have equilibrium point, and your indicator will show the change of color. That's how we identify equilibrium point.